Let g of x equal the square root of x. Find the derivative g prime of x. Using the definition of the derivative, g prime of x equals the limit as h approaches 0 of g of x plus h minus g of x all over h. G of x is the square root function here, so g of x plus h is the square root of x plus h, and g of x is the square root of x. It may look more intimidating than previous problems we've done with square roots, but multiply the top and bottom by the conjugate of the numerator, simplify until we can plug in h equals 0 without getting 0 over 0. The conjugate of square root of x plus h minus square root of x is the square root of x plus h plus the square root of x. And when we multiply the numerator and denominator of the fraction by the square root of x plus h plus the square root of x, we get the limit as h approaches 0 of the square root of x plus h minus the square root of x times the square root of x plus h plus the square root of x all over h times the square root of x plus h plus the square root of x. Since the numerator has the form a minus b times a plus b, which is the factorization of a difference of squares, a squared minus b squared, we can use a equals the square root of x plus h and b equals the square root of x to quickly simplify the numerator to the square root of x plus h squared minus the square root of x squared, which equals x plus h minus x, which equals h. This leaves us with g prime of x equals the limit as h approaches 0 of h over h times the square root of x plus h plus the square root of x. Now we can cancel the h from the top and the bottom to get the g prime of x equals the limit as h approaches 0 of 1 over the square root of x plus h plus square root of x. And then we finish the problem by letting h go to 0 to say that g prime of x is 1 over the square root of x plus 0 plus the square root of x, which is 1 over the square root of x plus the square root of x, which is 1 over 2 times the square root of x. Notice that while the domain of the original function, g of x equals the square root of x, is 0 to infinity with 0 included, since the square root of a negative number is not a real number. The domain of g prime of x, the derivative, is slightly smaller, 0 to infinity with 0 not included. 0 is no longer a valid input, since plugging in x equals 0 to 1 over 2 times the square root of x results in 0 in the denominator. We'll talk more about when the derivative of a function is and isn't defined later.